This is the ST Models Arcus M. At just over 2 meters wingspan, it is a treasure trove of built-in features. Spoilers, scale winglets, a fully enclosed, retractable power pod with integrated brushless motor and electronic sequencer. It even has the retractable undercarriage, all pre-installed into an easy-to-build model. Opening the box, I found the parts to be well packaged and organized with foam brackets to keep everything in place during shipment. In addition, all the pieces were individually wrapped in thin foam sheet. I did not find any parts damaged in shipment. In fact, I later realized that the model can be disassembled after construction and actually placed back into the box. Also included are some Y harnesses and extra Velcro. Lastly is the wing joining spar. Once completely unpacked, you can see that the Arcus has only 5 pieces to assemble, easily less than one night's work. The manual is a 15-page booklet with ample pictures, though most of the instructions were apparently for an unassembled version of the kit. So you can skip over most of the steps if you get the ARF version. There is also a fold-out supplement describing in detail how to set up the automatic power pod sequencer. The Arcus M requires at least a 4-channel radio, but you really want to use a minimum of a 6 or 7-channel radio to operate all the features. In this case, I used the Futaba 8J 8-channel radio, which was easy to set up. Starting with the fuselage, we see that the canopy is held on with a tongue and groove at the front and 2 friction keepers on the side. A non-retractable nose wheel is there as well. All of the servos are pre-installed and just require hookup to the receiver of your choosing. Both the retractable undercarriage and the power pod are protected by clamshell plastic doors. Here you can also see the power pod sequencer control board. This board has the option of automatic control or through the use of an extra channel manual control. The wings also have the servos pre-installed with plastic aerodynamic covers. In the ailerons are what appear to be embedded stiffeners to reinforce the thin foam. The spoilers come ready to use with the leads for both servos terminating at the wing root. All of the control surfaces are pre-hinged like we see here on the tail. Assembling the tail only takes a few moments. Simply feed the Z-bend rod through the elevator eyelet, mate the alignment pins on the top of the rudder, and finally screw it all together while you hold the horizontal stab in place. You must pay close attention to installing the wing spar. Since it sets the dihedral, you must place the point at the center facing down. Once certain of the orientation, simply slide it into one of the wing halves. Next, slide the wing and spar into the fuselage. To help in pulling the servo leads through the fuselage, I used a piece of scrap music wire with a hook on one end. Repeat for the other wing half and you are done. A single Jesus screw holds both wings together. Just be sure it is screwed all the way in. The Arcus comes with a 4mm HXT connector on the speed controller, which is not the type I use on my batteries. Instead, I will use the Star plug, which is Dean's compatible. Replacement of the plug is a simple affair. Cut off the factory connector. Strip and tin the wires. Solder on a new Star plug, which has a snap-on wire cap, and we are ready to go. The manual gives detailed instructions on how to set up the sequencer, though I did have to increase the throttle endpoints in order for the motor pod sequencer to arm. I tested both the manual and automatic modes of the sequencer, and to be honest, I preferred the automatic mode. Simply advance the throttle stick a few degrees and the mechanism automatically pops out. Advance the throttle further and the motor will power up. Pull the stick back to idle, and after a slight delay, the whole mechanism retracts neatly into the fuselage. One thing I must mention is that due to its design, the spinning proc may not stop in the correct position while testing on the ground. This is not a problem, as for when you are flying, you have airflow that will force the propeller into the proper position. The final touches include setting up the spoilers and landing gear to their respective channels and switches. Refer to the manual of your transmitter for how to assign channel switches. One last thorough check of all the systems, and we are ready to fly. The day has arrived. Despite overcast skies, we are go for launch.
So as you can see, the Arcus is really a really nice looking plane with great scale features, pretty much just like the real one does. But the question is, how does it fly? Well, let's find out.
I decided for the first flight that I would give my try at a ground takeoff. Motor up, a quick wiggle of the controls, and here we go. A little bit of nose dip, and she's up and climbing great. I was actually quite impressed by the rate of climb for such a modest power setup. I estimate a good 30 to 40 degree climb angle can be maintained. Once up, it was time to see how the power mechanism worked in flight. Throttle back to idle, and the rest is up to the electronic smarts. Which indeed worked like a charm. I found the glide performance to be very good, especially on a not so optimal late afternoon flight. I found the Arcus very good at working thermals despite my questionable thermaling ability. Not surprisingly, there's some adverse yaw when using the ailerons. Fortunately, the rudder is very effective and aids greatly in making turns. I would suggest mixing some rudder with ailerons to help in coordinating turns. Once comfortable with the trims and flying characteristics, I had great fun climbing and cycling the power pod in and out. I tried 2 different 3-cell batteries, the recommended 1200 mAh pack and a not much larger 1800 mAh pack. The 1200 mAh pack had a slightly better climb, but I actually preferred the stall characteristics of the 1800, which were straightforward, while a lighter 1200 would tend to dip a wing a little bit. This is my first glider with air brakes, and I was curious how well they would work. I must say I was pretty impressed on how well they helped bring the model down by killing the lift. On one flight, the Arcus simply did not want to come down, but when I pulled the air brakes, it had no trouble breaking out of the thermal and coming back down to earth. I noticed that with deployment of the air brakes, the nose would pitch down, so you need a little back pressure in the elevator to prevent excessive diving. So you may also want to consider mixing some up elevator with spoiler deployment. I would also be careful using them near the ground as they are very effective. Since not everyone has a nice paved runway, I decided to try my hand at hand launching the Arcus. After a couple of launches, I concluded that the best way is to launch at 1/3 throttle and then slowly throttle up. If you launch at full throttle, you have to be pretty quick on the elevator as the high thrust line of the power pod will force the nose down. However, once the speed has built up, this is not much of an issue. The Arcus is a foamy, so flights in high winds is not recommended, and you can expect a bit of wing flexing in flight. All in all, I found the Arcus fun and enjoyable to fly, and I look forward to the booming thermals of summer.